Hey everyone, thanks for joining. Hope you don't mind me facilitating this meetup in English, as it will be a lot easier with all the terms, and I also believe that the recording will be a good starting point for onboarding new team members in the future. So before we jump into the topic of reactive state management, maybe I should first introduce myself. My name is Chris, and I've been working with VMware for around 3 years now. I've had the luck to work on different projects with different state management approaches and needs, but all centered around one framework, which is Angular. So without further ado, let's see the agenda for today. First, we'll have a glossary of fundamental terms or concepts. Then we will see the built-in state management solutions that come out of the box with Angular, the problem with those, the solution of the problem, and we will dive deeper into the Ngrx architecture. And then we will see the outcome and a brief demo. After that, we'll have a Q&A session. So let's see the three concepts which are fundamental to today's topic. The first one is state. In one sentence, state is the data of our application that changes over time. We can think of state as the current snapshot of our application. It's the combination of all those individual states, like the user is authenticated, the model is open, or certain text box content, for example. That makes up the overall app state, and an app is described as stateful if it is designed to remember preceding events or user interactions. And this remembered information is called the state of our application. Basically, anything that can change within the context of our app may be called state. That was not that scientific, but I hope that it's understandable, at least. Next on the list is immutability. Immutability is the characteristic of an object with a fixed structure and properties whose values cannot be changed. So an object is considered as immutable when its state cannot be changed once the object is created. And such immutable objects provide a safer and consistent state. Generally, immutability can bring increased performance to our app and leads to simpler programming and debugging, as that data that never changes, it's easier to reason about than data that is free to be changed throughout our app. With that said, I've set the stage for the third concept, which is reactive programming. And reactive programming is essentially programming completely around asynchronous data streams, and it has no concept of mutable state. While imperative programs focus on the order in which computer does things and focus mainly on the code stack, reactive programs only care about the order in which things need to happen. They react to events and are written ignorant of the time and the context in which they are run. So now that we have an understanding of these fundamental concepts, let's hop into the state in an Angular component. The Angular framework, arguably even more than other ones, already has certain state management techniques built in. Just consider one of the main building blocks, the components. They act as a bridge between the client and the view state as they render and receive data via the template bindings. At the same time, components are TypeScript classes which can naturally encapsulate state through instance properties. This way, components are not simply responsible for the view synchronization, but also become state containers. And that's totally fine. Yet it can get difficult when we need some specific data in multiple components. In Angular, we typically overcome such difficulties through inputs and output bindings between the parent and child components. And consequently, our state will flow along the view tree. This gets tricky when some part of the state has to be shared between components that are fairly distant in terms of the tree. We would pull a lot of state into higher up components, if not into the root component itself, while the components in the middle might forward data that they're not really concerned with. And we are ending up with something that is called props drilling, as the properties we pass are all over the place and are really hard to reason about. To solve this issue, we have injectable classes called services that are coming out of the box with Angular. These class instances live outside of the view tree and can be injected into any component. Therefore, they're perfect for sharing state, right? If we be talking about other frameworks or libraries, this could have already been the point for proposing a state management solution, but in our case, services already enable us to build dedicated state containers, while components can focus on rendering views and triggering state changes back in the same service. Now that we've put our state into a service, sharing data gets easier, but we still encounter problems with managing it in a plain class properties. Particularly, it's hard to know when some state changes, especially when state objects can be mutated from all sorts of different places throughout our app. That's the point we can reach for observable streams and immutability. Our components can then listen to a stream of subsequent states while they send off commands via service methods. In practice, this approach is often based on RxJS subjects, and it's known as service with a subject pattern. To briefly explain what a RxJS subject is, it is a special type of observable that allows values to be multicasted to many observers, while with plain observables, each subscribed observer owns an independent execution of that observable. So now we are introducing a private subject in our service, and instead of returning a plain observable of the HTTP client response from the service method, as we would do in a pool-based architecture, we are instead subscribing to the observable returned by the HTTP client directly in the service method, so that when the server responds, we can emit the updated result by invoking the next method on our subject. This way, the updated data can be multicast to any component that's subscribed to the subject as observable that we are exposing through our service. Essentially, we've introduced an indirection following the CQRS pattern, or command query responsibility segregation, which gives us this unidirectional data flow. And by isolating commands and queries, there are now predefined ways in which state can change, and we can be sure that all consumers will be notified of those changes. Utilizing this service with a subject approach is already a pretty sophisticated solution, and in my opinion, many applications can do pretty well with it. It can go a really long way. So we're still not there yet. We still don't see a need for Ngrx as our state management solution. The thing is that while commands and queries are now technically separated, each component still has to know which command it has to send to which service in order to have its query resolved with the state it requires. Also, as we scale and our application grows, the number of commands will do the same, while some commands need to be propagated between different state containers. And when we throw asynchronous operations into the mix, it gets easy to create an entangled mess full of many stateful services, which are themselves full of race conditions. So let me show you what I'm imagining when I'm saying that. There's a high chance that if you've been developing Angular applications, and especially large-scale ones with many data sources, you've probably worked on something that resembles this application structure. When we introduce a bunch of services with shared state, for example, we have our user service, our authentication service, and some domain-specific services with holding domain-specific data. It can get quite messy, especially with asynchronous tasks and race conditions. So how can we untangle such situation? We simply don't have all the different services. We only have one which holds the global state, and we are now replacing commands with events, and we are introducing an event bus. So instead of issuing commands directly to a specific service, we now broadcast events globally, while each part of the state can react independently. To clarify a bit the difference between commands and events, commands represent something that should happen, while events represent that something has happened, and actions in the Redux pattern, respectively in Ngrx, which you'll see in a minute, are semantically events. So now, instead of telling some service to do something explicitly, we rather say, all right, this happened. Maybe it needs to result in some kind of state change, but the component doesn't really know that. It doesn't force the state change, and instead the service has full control of it. This is really nice for traceability purposes, and with Ngrx, we got great tooling support for that. And that's the Redux DevTools, which is a browser extension plugin, where we can follow the stream of what happened to our application, and we can time travel debug. That's really, really useful as we can go back to any particular state of our application, replay events in the same order, and see what could have been causing a defect, or to get a general understanding of how a feature works, what kind of events are being dispatched, in what order, and how they actually affect our application state. Now, let's see a high-level overview of how this Redux pattern is actually implemented in Ngrx. On this diagram, there might be some words which are a bit intimidating at first, but I'll do my best to explain them in very simple terms. So, how does the state gets updated? That global service which contains our global state is called the Ngrx store. You can think of the store as a predictable state container, which also manages the state. The store itself is a observable containing the current state, so every time a new state gets computed, it will push the new state to the subscribed components. And components can dispatch events which can result in a state change or a side effect. These events are called actions, as I mentioned earlier. So let's take a quick look at a component dispatching an action. Here on the left, we can see a simple component class which has the Ngrx store injected in its constructor, and by invoking the dispatch method of the store, it is dispatching the action that we pass as an argument. An action itself is a plain object that represents an intention to change the state in some way. And actions describe unique events. They're the only way to get the data in the store. So any data, whether from UI events, network callbacks, or other sources, needs to eventually be dispatched as action. The object representation of an action must have a type field that indicates the type of action being performed and can also have an optional payload of any type. And as we can see in the right section on the slide, to create an action, we are using creator util function provided by the library. Such creator utils are reducing drastically the boilerplate which Ngrx was once famous about. But we should have in mind that actions are just events. They shouldn't be like commands. They shouldn't tell the store what to do. Instead, the store knows what to do because of this funnel here in the middle called the reducer. A reducer is a function that accepts an accumulation and a value and returns a new accumulation. And these functions are used to reduce a collection of values down to a single value and are not unique to the Redux pattern or Ngrx. They're fundamental concept in functional programming. And as you may know, JavaScript has a built-in API for reducing. In Redux, the accumulated value is the state object, and the values being accumulated are the actions. Reducers do not mutate the state. Instead, they calculate a new state given the previous state and an action. Here on the slide, we can see that once again, we are taking advantage of another creator util function to which we are passing the initial state of our app and a couple of on callbacks for each of the actions that we want to result in a state change. You can think of that as a switch statement with all handled actions as cases of that switch statement. And actually in previous versions of the library, that's exactly how a reducer was implemented. It's important to know that reducers are pure functions, meaning that they should return the exact same output for a given input, and they should also be free of any side effects or anything asynchronous, which is great actually, because it makes writing unit tests for such functions a really straightforward process. As you can see on this test snippet here, we are just mocking a payload of the dispatched action, and we are expecting for it in the next state of our application, alongside with other changes to the state that are not related to the payload of the action, as in our case, the loading state. We're expecting that to be false. And reducers are probably the most important concept in Redux, and we can have dedicated reducers for different kinds of entities of state or even different features. As illustrated here, we have 4 reducers, one for each of the entities that we have in our initial application state. For example, we have one reducer for the state of the CPU, one for the state of the memory, etc. Each of these reducers is just a pure function accepting 2 parameters, the current state and the dispatched action. The reducer does not mutate the state, but from that information it gets for the current state and the event that happened in our application, this function just computes a completely new state object, and the store will do that anytime an action comes into it. Back to this diagram, after the next state is computed, the store will push it through an underlying observable to any component that is subscribed to the store. And most of the times we don't want the whole application state in a component. Therefore, we have just a slice of the state by the use of selectors. Selectors are pure functions used for obtaining just a slice of the store state. And because they're pure, the last result can be returned when the last result can be returned when the arguments match without re-invoking our selector function. And this practice is known as memoization. And such selectors are known as memoized selectors. And by utilizing such selectors, we provide great performance, particularly for the selectors that perform expensive computations in their projective functions. Let me now show you how a selector class for a feature looks like. Here on that snippet, we have a selector class with 3 memoized selectors created with the create selector function. The first one is getting the state object for that particular feature of our application, whilst the second one is using the state from the first one and returning only a property of it. That's how we are getting just a slice of the whole state of the store. The third selector is a bit more interesting as it uses the second one alongside with one other selector as inputs to the projector function, where it does some filtering. But here, instead of filtering, it can be any computation to get the desired data a component may need. And selectors are very portable and composable. With the latest version of Ngrx, we can compose up to 8 in order to compute data that some component or other selector may need. And I'll probably repeat myself, but unit testing pure functions is real simple, as we can just project the input data from the selector, from the selectors another one is depending upon, and we expect for the result to match the filtering criteria of the test selector, and it's that easy. Now, let me show you how selectors are being used in the context of a component class. Here we can see the same component that has the store injected, assigning the value from the store select method invocation to a local observable in its constructor. So we can then easily subscribe to that observable in our template with the async pipe, and our component will render the latest state updates. Just as easy as that. And actually the async pipe will automatically unsubscribe from that observable, so we don't have to think about memory leaks either. And essentially, this was the Redux pattern part of Ngrx. Now, this part on the right side is another indirection, which is arguably even more scalable, as we can just plug new receivers onto the event bus without modifying the sending side. Additionally, we can factor out the asynchronism there. So instead of having asynchronous command chains, tasks like HTTP requests can signal their completion through the event bus by dispatching a success or failure action. And that's done through effects. Effects are something that does not really belong to the store idea. And actually, Ngrx Store and Ngrx Effects are 2 separate packages because you can use the store principle already. You don't have to introduce the effects. The thing with effects is that we cannot run anything asynchronously in the reducer. We cannot have observables. We cannot actually reach outside of the funnel. We just have access to the current state and the dispatched action. There's no way of doing an HTTP request, for example. There comes this other library called Ngrx Effects. And it's this formalization of performing the asynchronous stuff in conjunction with the Ngrx store. What it does is it gets the action after it went through the reducer, funnels it through some effect, which can be asynchronous. It can go and fetch something, and once that's done, it just dispatches an action of success or failure. And the way we write this is with plain Reactive.js. Once again, we are using a creator util from the library to create an effect. And we are passing a callback, which returns the action observable stream, where we start with a stream of all the actions that come in our store. We listen for particular action with the off type operator, and then we switch map it over to some HTTP call. And once we have the response, we just map it back to a new success or failure action for the reducer to compute the next state, or maybe to trigger a chain of side effects. And unit testing in our case is not that hard, as we just have two cases, success and failure. And in both, we are expecting the following service method to have been called. And we expect the next dispatched action to be success or failure accordingly. Ngrx will also subscribe to the action stream for us and funnel all the actions that come out of it back to the store, and that's how we get the round trip. So to summarize, an effect is an observable which uses the action stream as its source and as its destination, meaning that an effect subscribes to the action stream and it can also publish to the same action stream. That's how we handle side effects and asynchronous operations with Ngrx. And to recap, I want to list the outcome and the biggest gains from using Ngrx as our state management solution, starting with predictability. As we saw, every Ngrx action produces a predictable outcome, and the store acts as a single source of truth, which is key. Therefore, we can avoid data inconsistency bugs, and we don't have to worry about data synchronization issues between different components. As we're just getting what our store holds. Immutability and performance. The store is built on a single immutable data structure, which provides the ability to utilize the on-push change detection strategy in most of our components, and that leads to greater performance, as Angular won't run the change detection for such components on every event in our app, but rather only when a value of an input changes. And also, Ngrx provides the memwise selector functions, which optimize retrieving data from the store in conjunction with computations on that data. And these two things alone provide a great performance boost. Then we have testability. As we are isolating the side effects from the UI, this makes unit testing very, very straightforward task, because the store uses pure functions for changing and selecting data from the state. And pure functions, as we saw, are really easy to test, as we should expect for the same output for a given input. We have encapsulation, once again, by using Ngrx Effects and store any interaction with external resources, side effects such as network requests or WebSockets, as well as any business logic can be isolated from the UI. And this isolation allows for more pure and simple components, and it upholds the single responsibility principle. So individual responsibilities around presentation, state transition, and HTTP requests are now all separate concerns. And since modification logic has been delegated to reducers and effects, there is no more need for tightly coupled components, which makes addition of new features a lot easier. Of course, throughout the data flow of Ngrx, we are leveraging the power of TypeScript, and we write our actions, reducers, selectors, and effects in a very specific way to get as much type safety out of the TypeScript compiler as we possibly can. And this lets us verify the correctness of our application at the data layer. And last but not least, as I mentioned earlier, we can hook monitoring tools to our application state to monitor the state in real time and time travel debug, which makes finding root causes for a bug or demystifying how an existing feature works a simple replay, rewind exercise, which I'll demonstrate in a second. And generally, the Ngrx store is just an all-in-one spot, and all mutations are explicit and tracked versus littered throughout the application and maintained locally by components. So let me jump in for a quick demo here. So we have our basic, actually, is my IDE shared? Can someone write in the chat if they see my IDE currently?
Yes, we're seeing it.
Yeah, thanks. So we have our typical Angular project structure. Here what we have is one other folder, which is the store, and we have the App Store module here. Here, just we have the bootstrapping configuration for the store. We are importing the store module with the for roots, and we provide some configurations as well as global reducers. We have the effects module, and here we have the store DevTools module with, again, with some configuration for the DevTooling that I'm going to show. Then what we have here, we have one feature which holds the components, containers, models, services, and store. And what we have here, we have some modules which are not really related to the store, but in the store folder, store folder, we have a store module, which once again imports the store and the effects for this particular feature. And we are providing it with a reducer for this particular feature and the effects which will handle the side effects for this feature. So let's start with the simple things, the state. We have an interface which is representing our state. Currently, it has just 3 properties. We have the loading, an array of VMs, and any error which is optional. We have the initial state where we initialize our application. And then let's jump to the actions. So we're having a bunch of actions like load the VMs, load all VMs, we are using the create action util, and we are just passing the type for this particular one. For the second one, load all VM success, which is, if we go back in the presentation here, yeah, actually here, we're having the effect, which will then trigger a success when we have fetched some data or we get a response from the server. So we have load all VM success or load all VMs failure accordingly. And I won't get into all of the actions, but we generally, they are just simple objects with type of the action being performed and properties. Then the one other interesting part is the reducer, which was the funnel in the middle of the diagram, where we have the initial state and we have these cases. If we refer to the reducer as a one big switch statement, this is the case for handling the load all VMs. In this case, we're just returning a new state object, and by providing the previous state or the current state, and we're just overriding the loading property to true. For load all VM success, we're getting the VMs from the server, which are passed as property to this action, and we are setting them in the new state. Also, we are setting the loading to false. Other interesting thing is the selector, as we are just getting the slice of the state, as we saw. Here we're getting the whole state for the feature, and here after that we are creating a selector. We are using the whole state for that feature, and we are just getting the loading property of it, or the VM's property of it in this case. The effects are probably the thing that's quite interesting, and it's usually the hardest to wrap your head around, because it has the observable streams concepts embedded into it, and sometimes it's harder for some folks to grasp, but yeah, essentially for this particular one, we have the action stream. We are piping it with a simple RxJS pipe, and we are listening for the type of the load all VMs action. And after that, we switch map it to a service call. And this service is just a pool-based service. Currently, it's a mock one, but it can just return HTTP client observable response, and it will be okay. And after we get the response, we can map it through the success or failure action. And the component structure is really simple. We have this one, which is container. Actually, this is one other pattern which utilizing Ngrx and the Redux pattern really provides us with. We can have container presenter pattern. For those that are not aware of that, we have container components which are store aware, so we are injecting the store in it, and we can have all the selectors here, and we can also dispatch the actions from those components. And in the template, we have other child components like the app VM form or VM list, which we'll see in a second. Those are presenter components, or they're also called dump components. So those components are not store aware, but instead they take, as we can see, there's no dependency injection here. There's nothing. They take the data from the store as observable streams to which we are subscribing here in the template, and they work via inputs and outputs only. So they will just render whatever data we provide in the input and output, so they're not aware of the whole store. And yeah, let me just show you this in action. So here we can see the Redux dev tools, which I've mentioned about, which is a pretty nifty plugin. So here we have the initial actions on load of our application. So we can see that we load all VMs, and this is how the state changed. We set the loading to true, and after that we set it to false, and we have the VMs already loaded. So, and we also can see on the action with the type and the payload of it. We can see the state at this moment of time. And for example, if we add a VM, we can see that we fired add VM action here. And as we can see, this is the raw state. We have the loading to true, and we have the VMs. And after add VM success is complete, we can see that we have the new VM here added. And let me show you this, as I say, is a replay rewind kind of exercise. So we can just go back to any state by jump or by using the slider here. And we can see at this state, the loading is true. So we are showing the spinner. And if we go even further back, we can see that the new VM was not added. So if we jump back to the last state, we can see that it is added, and this applies to all actions. So we can just essentially follow the stream of all actions, and we can also clean it if it's cluttered with many actions. But essentially, this thing is really powerful and allows for great traceability. Most of the folks on the call that have pulled their hairs out because of some bug because they're tracing the data and they don't know which service just emitted this and that. And yeah, this is really useful for those scenarios. So yeah, essentially that was it. So I'll leave off for the questions now, if there are any.
Hi, can we get access to that repo?
Sorry?
I was wondering if we can get access to the example repo.
It's not posted anywhere, but I can provide that. Actually, on the last slide of that presentation, I've left my email. So any questions or any queries, you can just ping me there, and I'll provide the repo. No problem.
Okay, thank you very much.
No problem.
Very nice presentation, by the way. Very clean, stick to the point. Thank you.
Thank you.
Hey, Chris, I have a question.
Hey, yeah, sure.
Yeah, have you tried integrating an Ngrx and Redux pattern in already existing application made in a Flux, like general Angular application that doesn't have a central store?
I have tried. It was not in an existing product. It was a side project, and I was just curious how will a store work with already an application which has another state management solution, or just using the service with a subject, and it plays well. You can just use the store as for just a feature or just a part of your application. And not the whole application. It works pretty well, but if the app is really if the data in the app changes from many different places and it has many different sources of data, I would probably consider starting by creating a new feature with the store and then maybe migrating the pre-existing features one by one or something like that, maybe.
Yeah, I think I see. I'm seeing your point. Here, my follow-up question is: what are the challenges by introducing Ngrx in already existing app? Do we have to somehow sync the Ngrx store with the rest of the states inside the application? If we deal with this, would this be enough?
As we saw, the state which the store holds, we're by using the selectors, they're just observables, so we can use them in an already existing app. So we can get the state. We can just inject the store in any component, and we can get the state from a part of the state from the store. And as far as the pre-existing state, I don't know if we can just, let me think a bit. I'm thinking that what's the previous structure of the example application you're thinking of?
Yeah, it's a general Angular application where each component is built with the Angular principles, like it can have its own template and component and service, and also there are you can have some general services that are used as either as a sharing some state or just requesting some data for all of the components.
So if you just bring the store and have all the old services, I don't think you get much, but rather if we have race conditions between the old services, for example, just bringing up the store for a new feature won't really fix the old issues. So I think that first of all, I would have unit tests for the old sharing state services in order to follow the data flow in the whole application, and then I would consider migrating it. But if you just want this for one feature, it's totally fine to have the Redux pattern for only one feature and continue with sharing state with other services, if that's fine.
Yeah, basically that was my question in a nutshell. Thanks.
Yeah, thanks.
Shall I consider, because I have yet another question? What are the drawbacks of using the Redux?
Oh, I was expecting that one. The drawbacks are actually there were more before because of boilerplate, but now that with Ngrx 8 there are new API with create util functions, the boilerplate was really reduced, and I think that it have a bit of a code cost, so you have to write more code to complete a feature, but in the end, it will be really robust, and you have all the advantages. It's not for Ngrx is not all-in-one solution for every Angular application. Some applications do well with just not even push-based services, just pull-based services. If they have only 2 or 3 domain-specific services, they should be pretty good with a pull-based service. But in some cases, the push-based service with a subject is also great sophisticated solution. It can go and satisfy many Angular applications. This one is more for if we have many data sources, and if you want data across many components. Like one example I can think of is maybe a simple shopping cart, or maybe Facebook Messenger, where you have the message pop in 5 different places on the screen, and this state is really shared across all those places. So in such cases, I would consider using Ngrx. And back to your question about the drawbacks, really, I think that you have to write just more explicit code. And am I audible still? Because
yes, you froze, like the video froze, but we are hearing you.
Yeah, all right, that's good. So other drawbacks are maybe from my stand of view point, it got a bit steep learning curve for someone who is not already familiar with the Redux pattern, and also with RxJS. You have to have a good RxJS knowledge in order to get a grasp of the whole concept, because it's observable centric. Other drawbacks.
Well, what I saw from your demo is, for example, when you described the transition between different states, I can imagine that if I have some state that consists not just in a loading field, but I can imagine a really big state of an application. So if I have to describe, for example, 50 states, wouldn't this become a very big file just to read it and to make a diff or to review some code changes? Can I split the file in more than a single one, or?
Yes, you can.
Okay.
You can have. I guess I assume that you are talking about the state object of the whole application.
Yep, I think so.
Yeah. You can have states for different features. So, for example, this is a feature state. Actually, it's VM state, and this will be in the. This can be put in. And slideshow, so I can easily find this slide. Yeah, here. For example, this is the whole app state, and we can have CPU state, which is a feature state. We can have other feature states, and they will have nested properties like nested objects and everything. And this should be fine.
Okay, thanks.
Sure. Are there any other questions?
Do you know some startup project that, for example, the people that are interested with this pattern can take a look, like the Heroes one for the Angular?
I think there is actually one article. I'll have to find it. Maybe you can contact me on the mail.
Sure.
Last slide. Let me just share that again. But there was one article that makes the tour of heroes with Ngrx. or migrating it. I cannot really remember, but I'll try. I'll do my best to find that one.
That would be good. Thanks.
Also, the docs for Ngrx are really good, and
yep, I agree.
As they're open source, they're getting better and better each time I open the doc. So yeah.
Oh, I can continue. Does this library depends somehow on the, I believe so, but on the TypeScript languages, on the Angular releases?
Yep, it depends. This is one challenge actually, which I forgot to mention, but we are currently facing, to have all the libraries in versions which are compatible with each other. But I guess that applies to most of the libraries out there. So there's nothing specific to Ngrx.
Yep. Do you have to instrument somehow your unit tests in some special way in order to test Ngrx's?
Yep, and yeah, actually, with ngmocks, you can provide a mock store, and this makes things easier. But without instrumentation, you will be also good, because, as we saw, most of the things are just pure functions, and the things that are not pure functions, where we have all the side effects in the effects module, we can test them as plain observables, either with subscribing pattern or marble testing, if that sounds familiar to you. But yeah, essentially, providing instrumentation would be better.
Yeah, makes sense.
All right, if there are no more questions, I'll be happy to wrap this meetup. And thank you all for having the time and attending the meetup. I hope it was helpful, and yeah.
Yeah, thank you for doing the presentation.
Thank you for the presentation as well. Just one question that came to my mind, probably a bit late, but I was curious if you guys are using some sort of a immutable library for the reducers in the project that you were mentioning, or like Immer or
yeah, Immer. Yeah, I'm aware of Immer, but I haven't really dig deep into Ngrx code base to see if they're internally using it, but I'm not aware if we are using it outside of Ngrx. But yeah, Immer it is great. I don't know if React's implementation of Redux uses Immer, right?
Oh, I haven't really looked at it, to be honest. I don't know.
I think it should be, but yeah.
Probably the new one with the Redux toolkit could be.